Here we have a problem on exponential equation. That is, we have to solve for x on the given exponential equation. Okay, here the first term of the given exponential equation is 2 to the x to power. So in the second term, at the exponent, we have the product of 2 and x. Okay, let us consider the power of a power rule in exponent. That is, let's consider the base a and consider exponent m for this base a. So we have a to the mth power. And for this complete stuff, I consider the exponent n. So now, what can we do with the two exponents over here? So whenever we have base a and we have some exponent for this base a, and for this complete stuff, again, if you have exponent, so what we can do is we can multiply the two exponents over here. That means m and n. So this is a power of a power rule in exponent. So then we'll be getting a to the power m times n. That is, we can multiply these two exponents. Okay, I'm going to use the power rule in reverse order. That is, so here we have base a at the exponent, we have two values are multiplied. So whenever two values are multiplied at the exponent, we can take one of the values as the first exponent for a, and for the complete stuff, the other value can be taken as a second exponent. So here 2 and x are multiplied. So now what I'm going to do is I'm going to take this x as the first exponent for this base 2. Then I'll be getting 2 to the x to power. Then I'm taking the other value 2 as the second exponent, I mean for the whole stuff. So equals to 20. Even if I simplify this one, I must be getting the original stuff. So here if I use the power rule, that is I have the base 2 and the exponent x, and for this complete stuff I have the exponent 2. So we can multiply the two exponents. When I multiply x and 2, I'll be getting 2x. So the stuff over here is equal to the original stuff. Okay, here I have 2 to the x to power, here I have 2 to the x to power. So to make the solving process easier, I'm going to assign a new variable for this 2 to the x to power. That is, let me assume there is a y equals to 2 to the x to power. So in this equation, wherever I find 2 to the x to power, it can be replaced by y. So here this 2 to the x to power can be replaced by y. Positive, this 2 to the x to power also can be replaced by y. Then we get y square equals to 20. Okay, now usually whenever I am writing an equation, the term with the largest exponent should be written at first. So here y is having exponent 2. So we can write y square at first, and then we can write y equals to 20. Actually, it's a quadratic equation, but to solve this quadratic equation for y, so we have to write this equation in the form of ax square positive bx positive c equals to 0. So that is the squared term first, and the variable with the exponent 1 next, and then constant term. Then at last we must have 0 on the right side. So here we have square term and the variable with the exponent 1 next, and but we have the constant term on the right side, but according to this form, we must have 0 on the right side. So we have to get rid of this 20. So for that, I subtract 20 from both sides. So when I do so, I'm getting y square positive y negative 20 equals to 0. Okay, now this quadratic equation is in standard form, and also the coefficient of y square is 1. So easily we can factor and solve this quadratic equation. Since the coefficient of y square over here is 1, so we can take the constant of negative 20, and we have to get two factors for this negative 20, so that the product of the two factors equals to negative 20, and the sum of the two factors over here must be equal to the coefficient of y, which is positive 1. So I think positive 5, negative 4 will satisfy the two conditions. That is, the product of positive 5 and negative 4 equals to negative 20. When I add them, I'm getting positive 1, which is the coefficient of y. Okay, so now the two values of y, we can get it from these two factors. So to get the two values of y, what I need to do is I have to change the sign of this positive y and sign of this negative 4. That is, here already it's positive 5. To get the value of y, I have to change this positive 5 as negative 5, and the other value for y is we have to change this negative as positive. Then I'm getting positive 4. Okay, now I got two values for y, and one is negative 5 and the other one is positive 4. Okay, actually y is a variable taken by us. It has to be replaced by the original stuff, that is 2 to the x to power. That's the original stuff. So to make the solving process easier, I just replace the 2 to the x to power in the given equation by y. So now we can replace the y over here by the stuff 2 to the x to power. So then we get 2 to the x to power equals to negative 5, and here I'm getting 2 to the x to power is equal to 4. Okay, here whatever value I have for x over here in the first equation, so this can never be a negative value. Even if I take x equals to 0, what will happen? 2 to the 0th power, it will become 1. If I take 2 to the first power or second power or third power, 2 to the first power means it will become 2, 2 to the second power means it will become 4. So it's a positive value. What if I take the negative value for x over here, 2 to the negative 1, for example. If I take x equals to negative 1, I'm getting 2 to the negative first power, then it will become 1 over 2. Still we get a positive value. So for any value of x is a negative value or positive value or 0, whatever it is, always it's positive. But on the right side, we have negative 5. So this equation will not be true for any value of x. So we can reject this equation, because whatever value I take for x, any real value for x, it can never be a negative value, but the result of this one has to be a negative value according to the equation, but that's not possible, so we can reject this equation. Okay, now let's consider this equation. So here I have to solve for the variable that is at exponent. Usually if I want to solve for a variable that is at exponent, what I have to do is I have to get the same base on both sides of the equation. Here on the left side we have base 2. So what I need to do is I should be trying to get the same base 2 on the other side, so that I can equate the exponent and I can solve for x. Okay, already we know that 4 is the power of 2, so that is 4 can be written as 2 square. Okay, now I got the same base on both sides of the equation. So now the two terms are equal with the same base 2. So since the two terms are equal with the same base 2, we can equate the exponents. So that is x equals to 2. So I have solved for x in the given equation. So the value of x is 2.